surface metal raceway is a metal enclosure system designed to enclose electrical conductors. Unlike embedded raceways, these are surface-mounted. The National Electrical Code, or NEC, defines specific criteria to determine if a through qualifies as a surface metal raceway. Firstly, the through must be installed exposed to view on the underside of a floor or roof structure. Secondly, it should not be concealed within a wall or ceiling. Thirdly, the enclosure must be a metal material that is independent of the building's structural components. Fourthly, the through must provide adequate protection to the enclosed conductors against physical damage, moisture, and dust. Considering a scenario where a raceway is planned to run under a raised floor in a computer room housing approximately 250 number 10 wires, its classification hinges on these criteria. If the raceway is installed in such a way that it remains exposed beneath the raised floor and is enclosed by metal, it aligns with the definition of a surface metal raceway. In this configuration, it offers the necessary protection for the conductors and adheres to the guidelines set forth by the NEC. Therefore, in this specific case, the through can be regarded as a surface metal raceway. The raised floor environment often necessitates this type of raceway to maintain accessibility and facilitate future modifications or additions to the electrical infrastructure. When selecting a surface metal raceway, several factors should be considered to ensure it meets the requirements of the application. Firstly, the raceway must have adequate capacity to accommodate the number and size of conductors to be installed. The NEC provides tables and guidelines for determining the allowable fill for raceways, which must be followed to prevent overheating and ensure the safe operation of the electrical system. Secondly, the raceway must be constructed of a material that is suitable for the environment in which it will be installed. For example, in damp or corrosive environments, a raceway made of stainless steel or aluminum may be necessary to prevent corrosion and ensure the long-term reliability of the system. Thirdly, the raceway must be properly supported and secured to prevent it from sagging or becoming damaged. The NEC specifies requirements for the spacing and type of supports to be used, which must be followed to ensure the raceway is properly installed. Fourthly, the raceway must be properly grounded to provide a path for fault current in the event of a ground fault. The NEC specifies requirements for grounding surface metal raceways, which must be followed to ensure the safety of personnel and equipment. Fifthly, the raceway must be installed in accordance with the manufacturer's instructions and all applicable codes and standards. This includes requirements for the type of fittings to be used, the method of installation, and the labeling of the raceway. When installing conductors in a surface metal raceway, several precautions should be taken to ensure the safety and reliability of the system. Firstly, the conductors must be properly insulated to prevent short circuits and ground faults. The NEC specifies requirements for the type and thickness of insulation to be used, which must be followed to ensure the safety of the system. Secondly, the conductors must be properly supported and secured within the raceway to prevent them from moving or becoming damaged. The NEC specifies requirements for the spacing and type of supports to be used, which must be followed to ensure the conductors are properly installed. Thirdly, the conductors must be properly terminated to ensure a good electrical connection. The NEC specifies requirements for the type of connectors to be used, the method of termination, and the torque to be applied to the connectors, which must be followed to ensure a reliable connection. Fourthly, the conductors must be properly labeled to identify their purpose and destination. This is particularly important in complex electrical systems where there may be many different circuits and conductors. Fifthly, the conductors must be tested to ensure they are properly installed and functioning correctly. This includes testing for continuity, insulation resistance, and voltage drop. In addition to the requirements of the NEC, there may be other codes and standards that apply to the installation of surface metal raceways. For example, some local jurisdictions may have additional requirements for the type of materials to be used, the method of installation, or the testing of the system. It is important to consult with the local authorities to determine what codes and standards apply to the specific installation. The selection and installation of surface metal raceways requires careful planning and execution to ensure the safety and reliability of the electrical system. By following the guidelines and requirements of the NEC and other applicable codes and standards, it is possible to design and install a system that will provide years of trouble-free service. For the specific scenario of running a raceway with 250 number 10 wires, you need to consider the ampacity of number 10 wire and the directing factors based on the number of current carrying conductors in the raceway. According to NEC Table 310.15 B16, the ampacity of number 10 copper wire with THHN insulation is typically 30 amps at 30 degrees Celsius. However, this ampacity must be adjusted based on the ambient temperature and the number of current carrying conductors in the raceway. When there are more than 3 current carrying conductors in a raceway, the ampacity of the conductors must be derated according to NEC Table 310.15 B3. For example, if there are 250 number 10 wires, and assuming they are all current carrying, the derating factor would be significant. To determine the exact derating factor, consult NEC Table 310.15 B3, which provides adjustment factors based on the number of current carrying conductors. If, for instance, the derating factor is 0.50, then the adjusted ampacity of each number 10 wire would be 30 amps multiplied by 0.50, which equals 15 amps. This means that each number 10 wire in the raceway can only carry a maximum of 15 amps. It is crucial to calculate the total load of the equipment being fed by the raceway to ensure that the adjusted ampacity of the conductors is sufficient. If the total load exceeds the adjusted ampacity, then larger conductors or multiple raceways may be required. In addition to derating for the number of current carrying conductors, it is also important to consider the ambient temperature in the computer room. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be further derated according to NEC Table 310.15 B2. This is because higher temperatures can cause the insulation of the conductors to degrade, which can reduce their ampacity and increase the risk of overheating. To determine the correct ampacity derating for temperature, consult NEC Table 310.15 B2, which provides adjustment factors based on the ambient temperature. Multiply the initial ampacity by the appropriate correction factor. For example, if the ambient temperature is 40 degrees Celsius and the correction factor is 0.91, then the adjusted ampacity of each number 10 wire would be 30 amps multiplied by 0.91, which equals 27.3 amps. After derating for both the number of current carrying conductors and the ambient temperature, it is important to select a raceway that is large enough to accommodate all of the conductors. The NEC provides tables and guidelines for determining the allowable fill for raceways, which must be followed to prevent overheating and ensure the safe operation of the electrical system. According to NEC Chapter 9, Table 4, the allowable fill for a raceway depends on the type of raceway and the size and number of conductors. For example, if using EMT conduit, the maximum allowable fill is 40% of the cross-sectional area of the conduit. To determine the required size of the raceway, calculate the total cross-sectional area of all of the conductors, including the insulation, and then select a raceway that has a cross-sectional area that is at least 2.5 times greater than the total cross-sectional area of the conductors. This will ensure that the raceway is not overfilled and that the conductors have adequate space for ventilation. In addition to selecting the correct size of raceway, it is also important to select a raceway that is suitable for the environment in which it will be installed. For example, in a computer room where there may be sensitive electronic equipment, it is important to select a raceway that is non-magnetic and does not generate electromagnetic interference. Aluminum or non-metallic raceways are often used in these applications. It is also important to ensure that the raceway is properly grounded to provide a path for fault current in the event of a ground fault. The NEC specifies requirements for grounding surface metal raceways, which must be followed to ensure the safety of personnel and equipment. This typically involves connecting the raceway to the building's grounding system using a grounding conductor. Furthermore, consider the physical protection required for the raceway and conductors. In a raised floor environment, the raceway may be subject to physical damage from equipment or personnel. Therefore, it is important to select a raceway that is durable and can withstand the expected level of physical abuse. Metal raceways such as EMT or rigid conduit are generally more durable than non-metallic raceways. However, non-metallic raceways may be suitable if they are properly protected by a physical barrier. When installing the raceway, it is important to follow the manufacturer's instructions in all applicable codes and standards. This includes requirements for the spacing and type of supports to be used, the method of installation, and the labeling of the raceway. It is also important to ensure that the raceway is properly secured to the building structure to prevent it from sagging or becoming damaged. To summarize, to determine if a through is considered a surface metal raceway under a raised floor with 250 number 10 wires, firstly, ensure the raceway is exposed and not concealed. Secondly, it must be metal and not part of the building structure. Thirdly, the raceway must protect the conductors from damage, moisture, and dust. Fourthly, calculate ampacity rating for the number of conductors and ambient temperature per NEC guidelines. Fifthly, select a raceway size based on conductor fill requirements. Sixthly, consider environmental factors and grounding requirements. Seventhly, adhere to all applicable codes, standards, and manufacturer's instructions for installation.